For the first problem right here, I've written solve the equation 3 plus 1 over x equal 10 over x squared. Now notice that we have a variable here in the denominator, so if by chance I solve this equation and I end up with x equals 0 as one solution, I can't use it because you cannot divide by 0. So we have to check that every time we see that the variable appears in a denominator. Well, what I'm going to do to begin this problem right here is clear it of fractions. I'll take my least common denominator, which is x squared, and simply multiply both sides by it. Now I'm not going to let x be 0 anyway, so I know I haven't multiplied both sides by 0. X squared times 3 will be 3x squared. X squared times 1 over x will be x. And then 10 over x squared times x squared will be 10. So I end up with 3x squared plus x is equal to 10. I'll put this in standard form. 3x squared plus x minus 10 is equal to 0. I'll factor this. Let's try 3x and x, and how about 5 and 2? Inside I have 5x, outside I have 6x, so that should work. So 3x minus 5, x plus 2 equals 0. Is that right? Negative 5x, positive 6x is positive 1x. So I set 3x minus 5 equal to 0, and I set x plus 2 equal to 0. Here I add 5 to both sides, then divide by 3. I end up with x equals 5/3. Here I add negative 2 to both sides, x is equal to negative 2. Notice that neither one of those two numbers makes anything in the original equation undefined. So those are my two solutions. I'm going to keep both of them. Let's look at our next problem. Here I want to do the same type of thing, but before I see what the least common denominator is, I'm going to have to factor these denominators. So y minus 4 divided by y times y minus 5, and here I have 2 over y plus 5, y minus 5. So my least common denominator is y times y minus 5 times y plus 5. So I'm going to take that least common denominator and I'm going to multiply this side of the equation by it, and then I'm going to take the least common denominator and multiply this side of the equation by it. When I multiply on the left side right here, y and y minus 5 will divide out. What will be left to be y plus 5 times this numerator y minus 4. So y plus 5 times y minus 4. When I take my least common denominator and multiply it times this side of the equation, y plus 5 and y minus 5 will divide out, and what will be left is y. Now I need to put this equation in standard form, so let's see, we have y squared plus y minus 20 is equal to 2y. I'll add negative 2y to both sides and have y squared, what do we have here, minus y minus 20 is equal to 0. When I add negative 2y to both sides, over here I'll end up with a negative y. Now I factor y minus 5, y plus 4 is equal to 0. I set this factor equal to 0, and y is equal to 5. I set this factor equal to 0, and y is equal to negative 4. Now notice that if I take y equal 5 and substitute it back into my original equation, this denominator right here is going to be 0, and so is this one. So I can't use y equal 5. It's an extraneous solution. It would also mean that I multiplied both sides of the equation by 0. If I take y equal negative 4 and substitute it back into my original equation, I'll get a true statement. Y equal negative 4 does not make either one of these denominators equal to 0. So when you solve equations like this that involve fractions, you end up multiplying both sides by expressions that contain a variable. You need to check to see that there isn't any solutions to the equations that make that expression that you multiplied both sides by equal to 0. Because if there are numbers like that, they're called extraneous solutions and we can't use them.